Hello everyone. So this is Safe Software and I have designed a math footing for a 23-story building which I have designed earlier. So this is the model of the footing I have made. So first we have to define the materials. So go to define the materials. So these two materials I have defined M40 and HYSD 500. M40 for concrete, HYSD 500 for longitudinal bars, rebars. So these all property you have to input, you can get it from internet. And similarly for HYSD 500. Now, after defining materials, we have to define slab properties, footing properties. So you create here mat footing, modify shoe property, here M40 slab material and thickness. First I have assumed 500 mm, but it was failed, so I increased the thickness of the footing. So this is 1200 mm. Then after defining material and then slab properties, then we have to define column properties. So two types of column are there, 500 by 500, 600 by 600. So you can see the properties of this column, M40, 500 by 500. So the outer columns are 500 by 500 and these four columns are 600 by 600. So after defining materials, slab properties, column properties, then we have to define the soil subgrade properties. Soil, modify. Here subgrade modulus we calculate from the formula. Subgrade modulus equal to SBC by allowable settlement. These values will be given as per problem statement. So it's coming 330,000 kilonewton per meter cube. So first material, then slab properties, then column properties, then soil subgrade properties. Then we have to define the loads, load pattern, load cases, and load combination. So in load patterns, we have assigned dead load and live load. Self-weight multiplier 1. Then load cases, dead load, live load, linear static type of analysis. Okay. Then load combinations. So there are two types of combination as per IS 456. Ultimate load combination, which is combination 1 here. So in ultimate load combination, the scale factor for dead load and live load is 1.5 respectively. And here strength ultimate design selection. Okay. In combination 2, that is combination for serviceability. The scale factor for dead load and live load is 1. And linear combination type, and here design selection you have to take all service normal, so service long term and service initial. Okay. Then here define material properties, slab properties, column properties, soil subgrade properties, and all the loads. So definitions is all complete. Now you have to draw the footing. We draw the footing by going to draw menu and then draw columns and draw slab areas and draw design strips. So these are design strips. Then you can display, show. Then after drawing the footing and all, you have to assign the soil properties and load data. So here, from here you can go to soil properties, and here from here you can now right click here anywhere in the footing. You will get the properties here: rebar material HYSD, boards, mat footing, soil. Then if you immediately click on this column, you will get the loads. This is dead load, point load, this is live load, dead load this, and here design. So in column, if you want to see rebar, then here go click inside the column but not at the center. You will get And then after assigning all loads and soil properties, you can go to run analysis. Already I've run, then run analysis and design, and then run detailing. So everything is already done. So here in detailing option, you can see various, this is reinforcement profile, V-bar plan, then you can go to rebar schedule, this is all schedule, bill of quantities, and you can see everything here. And display undeformed. Then you can view, check if you want to check already punching sheet design is checked. So this was the design.
Thank you.